Assalamualaikum. My name is Nurul Zuhairah from Universiti Kuala Lumpur. The title of my presentation today is a short review of the permeability approach via experimental and modeling work of fibre reinforced composite and the factors affect permeability behavior during impregnation process. In this paper, a short review on the permeability study of fibre reinforced composite for both synthetic and natural-based fibre respectively are presented. The review summarizes the research paper which focused in the experimental, theoretical and modeling work that related to the permeability studies. In addition to that, this review paper highlighting a few research studies conducted in the literature on the main factor affecting the permeability behavior and lead to the effect of the performance for the composite. The aim of this short review mainly to capture the trend ranging from the recent 5 years back and summarize the various studies conducted in order to provide a baseline study for the selection of the most appropriate methods for the permeability determination of the woven fabrics during the impregnation process of the composite in the author's work. Permeability is defined as a scenario of how easily a liquid or fluid flows through a porous material. Material with a high permeability allow easy flow, while material with a low permeability resist flow. It represents, for composite reinforcement, a measure for their ease of impregnation by a fluid resin. Permeability K is the property of the material, in this case a woven fabric, in which allow the flow of resin impregnated to the woven fabrics. The permeability of the woven fabric with a different type of the wave pattern is to be determined with regard to the flow of the thermoset-based resin during the impregnation of the solution coating process, that with the aim of to identify and select the reliable method for the permeability measurement during fabrication of the pre-impregnated material, especially when using natural fibre reinforced fabrics. Permeability is the key parameter in any processes. It is a well-defined concept, but still a difficult parameter to quantify, in large part because textile reinforcement are not constant in their internal geometry and the architecture itself. There are few main factors affecting permeability behavior of the composite, which are fibre reinforcement, resin or fluids, and processing condition. For the fibre reinforcement, the main factor with regard to the fibre reinforcement itself related to the type of the woven fabrics, geometry, and architecture on the structure. They are also related to the type of the wave pattern, stacking sequence of the laminate, weight or volume fraction of the fibre, as well as the fibre compaction behavior under certain conditions. On the other hand, for the resin or the fluid itself, their rheological properties itself, such as shear stresses, viscosity and shear flow rate, as well as viscoelastic modulus, are the factors also contributing to the permeability behavior of the fabrics. Apart from that, the processing condition also contributing to the permeability behavior with regard to the such as temperature, time, pressure, as well as the resin inlet point, for example, in the processing such as LCM for the liquid compression molding. The solvent coating process, in this case with regard to the author's work, is the process to impregnate the fabric with the resin. The solution coating machine being used in order to carry out the impregnation process, in which the fabric material is then being running through a bath of resin in the dipping process, where the capillary forces ensure the wetting of the material itself. The viscosity of the resin solution is then controlled by the solvent content in the bath, and the film is specifically necessary to avoid contamination to make sure the prepreg does not adhere to itself during the storage and to facilitate the handling. Based on figure 1, The research studied permeability measurement using various types of resin or liquid such as epoxy, polyester, polyethylene, vinyl, with the most common resin used the impregnation process is epoxy-based resin. However, in the permeability determination and characterization, there are few other types of the liquid is being used by various researchers as their test fluid in replacing the various thermoset resin. Among of them, such as silicone oil, mineral oil, corn syrup, motor oil or engine oil, and distilled water are commonly selected. The key point is to ensure that the selected fluid have no any particular interaction with the fabric reinforcement, such as in the case of the use of water-based fluid with the natural reinforcement. Apart from that, the test fluid also should have properties close to those of the resin used. This is in terms of their viscosity and rheological properties in the measurement of the permeability. The rheological behavior analysis of the resin should be carried out in providing the benchmarking study for the selection of the fluid or liquids being used. It is also important to study the rheological properties in order to study the behavior of the resin during the impregnation process with the behavior of the fabric architecture and their morphology under different processing conditions such as high temperature and pressure with the intended specific method of manufacturing process. A summary of research paper investigated on the permeability study of fibre reinforced composite using various types of fibre is shown in the figure 2. Most of the researchers from recently up until 2020 have selected the synthetic fibre as their main material for the permeability measurement as compared with natural fibre. The main advantage of the synthetic fibre offered compared to the natural fibre is because nowadays the property of the synthetic fibre keep improving with the continuous enhancement of the technology itself. The variation of the fabric architecture has been studied by means of image analysis by various researchers recently. For example, in a work by Habibi et al., the investigation of the permeability of the flat reinforcement focused on the effect of the surface density and fibre length, which showed that the impregnation of the dry fibre reinforcement with a liquid resin is the key for the processing time and the mechanical performance of the fabricated part. A similar kind of work also conducted by Karaki et al. 2017, who investigated a comparative analysis of the microscopic permeability of fibre bundles in composite materials. An extensive reviewed analytical models calculation were compared with numerical and experimental results from literature work. It was concluded from their works that the researcher who predicted the permeability values using different approach used to approve their result by comparing them with a selected experiment, a selected model, or a selected numerical simulation from the bibliography instead of doing a generalized comparison. From their study, it is noted that it is important to select the best experimental and analytical models for comparing and predicting the permeability values for the fibre reinforcement. This is also supported from the study by Cosson et al. 2018 that natural fibre-based fabrics may present a greater variability of the properties such as local fibre volume fraction and corresponding variability to resin flow than that observed on synthetic fibers such as glass. By having this factor, it is crucial to track the variability and quantifying the material density distribution in order to optimize natural fibre reinforced composite. In the case of the author's work, apart from this short review, it may require further extensive literature review work in selecting the most appropriate methods for either experimental, analytical calculation, or numerical analysis work with regard to the study of the impregnation process of the natural woven fabric with the epoxy-based thermoset, specifically in the solution coating process using the lamination machine, as there is a very limited literature being found related to the proposed work. In conclusion, a short review of the permeability study of fibre reinforced composite for both synthetic and natural-based fibre are presented and summarized. The Main factor affecting the permeability quality has been highlighted, and why is it important to study this scenario with a review of the research study has been conducted. This is in order to provide a baseline in the selection of the method for the future works of the authors with regard to the permeability behavior during the impregnation process of the fibre reinforced composite, especially when using natural-based fibre in order to ensure a better composite product quality can be produced. The factors that affect the permeability of the paper in the solution impregnation process have been evaluated by various researchers, in which summarized by the fibre architecture, the resin type, as well as others factors. This preliminary study provides some insight and required further detailed work with regard to the literature in the selection of the permeability models and the experimental method to be carried out later on. That's the end of my presentation. Thank you for listening. Assalamualaikum warahmatullahi wabarakatuh.